Radio astronomy is now an interesting and beautiful part of astronomy. It makes up a key role in our observations of the universe. Where did it start? Optical astronomy makes immediate sense. We see a star, we make something that improves our ability to see it. But how did radio waves start? How did we decide to work with them? Let's start with James Clerk Maxwell. He made equations describing electromagnetism, and one of the nice fallouts from that was a change in the way we view light. The equations lead to the idea of electromagnetic radiation, of which the visible light we see is one of a small range of wavelengths. This leads us to ask, well, what about other wavelengths? In 1888, German physicist Heinrich Hertz developed the first radio antenna. He was trying to verify Maxwell's idea of electromagnetic radiation at other wavelengths. He made something to allow himself to emit and detect radio waves. Now we can make the parallel with optical astronomy. We can see these wavelengths. Shall we see if they're coming from space? However, there were many early attempts that failed simply due to the quality of the equipment that was around at the time. That improved, and then along comes a man called Karl Kenski, working at Bell Labs. Radio's developed since Hertz, and he's now looking at interference in transatlantic transmissions. It's very slow work where he looks at all the sources of interference and tries to categorise them into distinct groups. He finds a source from nearby thunderstorms, another source that can be related to distant thunderstorms, but also a signal with no known origin. He looks for anything that might identify it and realises that it has a periodicity of around 24 hours. So okay, this may have something to do with the sun. A lot of discussion with other scientists later, and it's discovered that this periodicity matches what's called the Sidereal day, which is the day in terms of distant astronomical objects. So how long between when a distant object passes the same point in the sky. Jansky concluded that the signal peaked when the antenna pointed around a part of the Milky Way near a star called Sagittarius A star, which we now know is the densest part of the Milky Way, around a supermassive black hole in the middle of our galaxy. What Jansky used was an array of dipoles and reflectors mounted on a turntable, and there's a replica which I've used a photo of, which can be seen in Green Bank, West Virginia. What's interesting about this is it opens the door for radio astronomy. We have a signal that good evidence suggests is extraterrestrial, and we can detect it on Earth. After this, Grote-Reber built the first dish-style radio telescope, and from that point on we've been slowly improving our ability to work in the radio wavelength. That's a story for another day.